Hello, good morning, good evening, good afternoon, wherever you are in the world. In our next session for the PASS Summit 2014 preview, we got Jes Borland talking about indexes. Do you know if your indexes are helping you or hurting you? Next slide.
Not too fast. There we go.
So if you guys require any assistance, you can type your question on the question pane on the right side. If you need to zoom your screen, you got a zoom button on top of the presentation window, and any questions in relate to the presentations can be put on the question pane, also on the right side.
And at the end of my session, when I'm done going through my information, Daniel will be asking me the Q&A directly.
Sure, yes. Next. Now we need to thank our sponsors because without them this wouldn't be possible, in special Microsoft and Dell software. So have you registered for the PASS Summit yet? So if you're planning, now is the time because until September 26th you can save $200 using the discount code 24HOP14. So that's the world's largest gathering of SQL Server and BI professionals, and it's going to be, I think it's about more than 190 technical sessions, which has over 5,000 attendees representing lots of countries, and I know that I'm going, so you should be too.
Come meet Daniel.
Come and meet me, yes, I'm coming from Australia. So now let's speak about Jes Borland. She's a Microsoft SQL Server MVP, and she's a consultant for brand Ozar Unlimited. She holds an AAS Programmer Analyst degree. She's the president of FoxPass. She's the founder of Tech on Tap, and she blogs for lessthandot.com. So now I present you guys Jes Borland.
All right. Thanks, Daniel. So welcome, everyone. As Daniel said, whether it is morning or afternoon or evening where you're at, I am here to talk to you for the next 45 minutes or so on determining if your indexes are helping you or hurting you. At the end of this session, I want you to be able to make better indexing choices. I want you to know if the indexes that you have in your database are solving your performance problems rather than contributing to them, or at the very least, not helping them. So when I first asked the question, are your indexes helping you or hurting you, I think it helps to define how does an index help you and how does an index hurt you. As a consultant, I get to see many, many different systems, small to large, a small number of transactions with a large number of reports, or very large number of transactions, a couple of reporting style queries, and these are just some general things that I can tell you after looking at dozens of different systems. The indexes that help us in our database help retrieve data faster, whether that's to do a select query or whether that's to get information to update another set of records. And they do not slow down our data modification queries significantly, so they don't make our insert, our update, our deletes even slower. On the other hand, indexes that hurt are out there in our database. They're not taking up space, but they are being used by data retrieval queries. They're slowing down our insert, updates, and deletes. So I'm here to help you navigate the world of how can we find those that are hurting us and how can we make them help us instead. So just a quick recap on index basics. And to kind of set the stage, some things I'm not going to be covering because they're a little bit more advanced. I'm not going to be talking about special types of indexes. XML indexes, spatial indexes, filtered indexes, column store indexes, the new memory optimized indexes in SQL Server 2014, indexed views. We're going to be sticking to the solid basics, talking about heaps and clustered indexes and non-clustered indexes. Because just like those things, there's a lot of things you can do to your indexes in your database that will help you and not hurt you. So to recap, when we start out with a table full of data, unless we specifically apply a clustered index, we have a heap. A heap of data is an unordered collection of data. It may or may not be sequential depending on how it's entered, how it's updated, has it been deleted, that sort of thing. Understand, though, that the heap does include all of the columns and all of the rows in the table. So it's all of your data. If we want to, we can apply a clustered index to our table. To do this, we specify one or more columns that are our key columns. And SQL Server stores this as what we would call a reverse B tree. And the data is retrieved in order by the key columns. So if we have a list of customers and we assign them ID numbers from 1 up to an increasing amount, customer 1, then customer 2, then customer 3, then customer 500 and 1017 and 5700. One thing to note is that we can't guarantee that on each individual 8K data page in our database that the records are stored sequentially in order on that page. That's some internal stuff that I won't be getting into here today. We'll talk about more at Past Summit. Note that a clustered index, much like a heap, still contains all of the columns and all of the rows in the table. It has all of your data. So, lacking any other indexes or a not appropriate index for the query that you're running, SQL Server will turn to your clustered index to get the data it needs for a query. So to help make queries and searches faster, we can and do create non-clustered indexes. So again, with non-clustered indexes, we pick one or more columns as the key columns. Again, the data will be retrieved in the order of the columns that we specify. Now, a non-clustered index helps make the data retrieval skinnier or narrower because it only contains the columns that we specify, a subset of the columns, but it still contains all of the rows. So rather than our non-clustered index containing all 15 or 20 or 40 columns from our table, maybe it just contains 5. This means that we can fit far more rows on a single 8K data page. That means we have to read fewer pages to return the results of a query. It helps reduce the I/O for running queries. Now, I'm going to let you in on a little secret. This is something that I confess I didn't know for years. It never occurred to me that when you have your clustered index as one data structure in the database, and you have a non-clustered index as a separate data structure in the database, that there would have to be some way to link the two. I guess I thought SQL Server just did that by magic. It doesn't. When you create a non-clustered index, along with the 1 or 2 or however many key columns you choose, SQL Server will also store the clustered index key column or columns with every row. It has to be able to point it back to the clustered index, in case it needs to retrieve some additional information. So thus, when you're creating non-clustered indexes, you do not have to specify the clustered index key columns again. SQL Server will automatically include them. If you want the clustered index key to be part of the non-clustered index sorting order, you can still explicitly include it. Note that this does not mean that the clustered index key is stored twice, because it isn't. It's still there once. But I had no idea that was there, and I had no idea it could hurt us in times. How is that? Well, the wider our clustered index is, perhaps if we even have just one key column, it's very wide, like a GUID, for example. Or perhaps we have a large clustered index. We have maybe 4 or 5 columns and they're wide. If that key is stored with every non-clustered index, then the non-clustered indexes all get that much larger. So carefully consider that when debating what keys you are going to use as your clustered index key and how that's going to affect non-clustered indexes on that table as well. So now what we really want to talk about is how we can help make our indexes help us. So your first mission is going to be identifying your server's workload. Being able to design your indexes for the type of workload that you have is the first step into making the right indexing decisions. So there's 2 main workload types. We have OLTP, or a standard transactional system. This is something that has a lot of inserts, maybe a lot of updates as well, some deletes. It's typically characterized by small, quick transactions, and when we're doing data retrieval or select statements, we're typically only getting a few rows at a time. The other side is the OLAP, or analytical reporting style workloads. These might have many data retrieval queries. They probably have a lot of aggregations, sum, count, min, max, windowing functions. They can be large, long-running transactions that are aggregating days, weeks, even months of data. And when we go to update them, rather than inserting 1 or 2 rows here, updating 1 or 2 there, we're typically doing large batch updates. Doing a large BCP from our transactional system into our data warehouse. We typically try to index for these 2 scenarios differently. In the case of an OLTP workload, I want my writes to be fast. I'm doing a lot of writing, a lot of inserts, lots of updates, a few deletes. So I want a few very selective non-clustered indexes, and I want them to be narrow, right? I don't want them to be most of the columns from my table. And we'll see why when we get into some of our demos later in this session. When I'm designing for an analytical or reporting system, I want to have my reads be fast. I want indexes that support my aggregations. I even may want to have wide indexes. In my table, particularly if I'm using some sort of specialized schema, may have dozens of columns, and I might need 15 of them to efficiently return the results of the query. So we do design indexing scenarios differently based on what our workload is. How can you tell? Well, there's a couple of different ways. You can start by looking at queries that have already executed on your system, investigating your execution plan cache. You can use SQL Server's built-in DMVs for this. We have sys.dm exec cache plans and dm exec query plans. Rather than looking at it historically, you could also use some tools to capture your events in real time. For those of you on 2012, 2014, I'd recommend setting up an extended events session to capture things like what stored procedures and what SQL statements execute. If you're on an earlier version, use something like a server-side trace. This can be especially useful if you aggregate the results with a tool like ClearTrace. There's a lot of great tools out there for capturing your data and your workload. Once you're aware of what your workload is, then the next mission that you have is to identify what indexes currently exist. Now, if you're at the point where you're just building a brand new system, designing a new database, you probably have a lot of freedom and a lot of questions, but most of us, I assume, that are on this call are looking at systems that we designed years ago, or someone else designed, or our vendor systems. And we need to know what indexes already exist. So you have some options. If you're looking for a very specific table, you could go into SQL Server Management Studio, expand the database, expand tables, go to indexes, and use the Object Explorer to script them out. But that can be time-consuming, especially if you have to do that for multiple tables or want to do it for all the tables in your database. Again, I prefer to turn to T-SQL and use the sys indexes and sys.index columns system views. Also, my team, the Brent Lazar Unlimited team, has created an SP Blitz index tool which can help you diagnose what indexes you have existing. So just as a quick screenshot, if I were to use sys.indexes, I could get a list of the table name, what indexes exist on it, what type they are, such as clustered or non-clustered, and then I've returned some additional information, such as, is it a unique index? Is it a primary key? Is it part of a unique constraint? Again, I'll be going more in depth into queries on how to tell what indexes exist in my past Summit full session. But know that there are lots of tools that you have available to help you determine what indexes exist. And once you know, do they exist, then you want to know, are they helping me? Are they being used? How are they being used? So let's go back to focusing on how non-clustered indexes help us. Primarily, our non-clustered index key columns are there to support what's in our where clause. When we write a query to select some data, we say where the date is in this range, where a name is equal to this, where a product number is within this range. Our non-clustered indexes should support what predicates we have in the where clause. And the order of our index key columns and the order of our predicates matters. Let's pop over to SQL Server Management Studio and I can show you this. So in SQL Server Management Studio, and let me make this a little bit easier on the eyes, I am going to create a new table called Where Clause Demo. I have actual execution plans turned on, and I have stats.io turned on, so excellent. I'm going to do a really simple, although not best practices query here, and just select star. I can see I have 31,000 rows returned. Looking at my I.O. by using the statistics I.O., I can see that I've done 158 logical reads, and I'm doing a table scan because I don't have any indexes on it yet. It's reading through all of the data to return my 31,000 rows. Now, typically, we don't just select all of the data from the query and send it back to our report or application. We narrow it down with a where clause like this, where the order date is greater than 1/1/2007. Okay, I've narrowed my results down, 26,000 and some now. But if I look at my statistics here, I can see I'm still doing the same amount of reads, 158. And I'm still doing a table scan. So simply adding a where clause to our query doesn't help us if we have no indexing to support it. So I'm going to add a primary key clustered index to this table on the sales order ID column. So let's refresh my table list. We should have where clause demo and a list of columns. So now this clustered index is going to exist as a physical object on disk. It's going to contain all of the columns in my table: sales order ID, order date, due date, ship date, and purchase order number. Now, I know that I am primarily going to be searching this table based on different dates, so I create a non-clustered index with 3 key columns: order date, due date, and ship date. So now I'm going to run a couple of queries, and we're going to take a look at how those are affected. So what I want to do here is split the screen and just keep that non-clustered index creation statement up there so we can reference it. The first thing I'm going to do is query based on the first column, my first key column, order date. Let's see how that affects our query. We return fewer rows, 43, because I've specified where the order date is equal to July 1, 2005. Note that my logical reads have been reduced significantly from 150 some to 2. And I've gone from doing a table scan to a non-clustered index seek. So because instead of storing all of the columns in the index, I'm storing far fewer, and because I have a very narrow where clause and an index to support it, I can reduce my I/O. My query cost 0.0033293. Now what happens if I run the same query, but my where clause is on the ship date column? I only get 2 rows this time. That's a much narrower range. But notice my reads have increased. So now I'm doing 135 logical reads. And this time, instead of doing an index seek, I'm doing an index scan. So SQL Server has chosen to use my smaller non-clustered index because the columns it needs to search ship date and it needs to return order date, exist in IX_where clause. However, if we select that index scan and we go over to the properties, we can see some things over here, such as it is not an ordered search. So the order of the key columns in your index and the order of the predicates in your where clause does indeed matter. So if I was to do a similar query where I had ship date and order date, I'd get 5 rows this time. And again, a different number. This time I'm doing 5 logical reads. So SQL Server is now doing an index seek, but it has a higher cost. If I were to rewrite that query to match my index, putting order date first and then ship date, I'm going to see an index seek, so let's run these both together. No, let's not try to create a new query. So my first one has 5 logical reads and the second has 5 logical reads. Both have a non-clustered index seek. The cost here, 0.005426, and this one also. Now, what about if the non-clustered index we had now is asking for columns that aren't in the index? For example, I want to select sales order ID and purchase order number from the table. I'm still going to use the same index, I hope, because the order date and the ship date is in there. Well, I get 5 rows returned, But again, my logical reads have increased. What's happening? I now have an extra operator in my execution plan. So note that I'm doing an index seek on the IX where clause, and I am doing a clustered index key lookup. So let's go back to our slides to talk about that. What about our select statements? We typically will index for the where clause. Like I said, that's what determines which indexes SQL Server will consider. But if we also want to return additional columns in our select statement without having to do that additional operation, we can add included columns. You may be using those in your indexes. So included columns are also stored on the 8K data pages, but the order of them isn't as important. They are not stored in order like the key columns are. So that's not guaranteed. Using included columns can be very helpful, unless it's using a majority of the columns from the table. So if you have a table that's 20 columns and you include 10 of them, is that really any less impactful than just having SQL Server do the index scan and the key lookup? There's going to be a certain threshold, and I can't tell you. Sometimes it might be 25% of the columns, sometimes it might be 50%, sometimes it might be 60%. That means it's too much. You really have to test it out in development. Try, how many of the columns that are in the select statement should I include before the cost of doing one massive index seek outweighs the cost of an index seek and key lookup, or index scan and key lookup. So let's go back to SQL Server Management Studio and we'll take a look at how we can make this query more effective. So here is exactly the same query I just ran. Again, we're looking at sales order ID and purchase order number based on the IX_where clause. We see that we're doing an index seek and a key lookup. I can create another non-clustered index on this table to support this query. You'll notice that I have two key columns, order date and ship date, and then I add the include purchase order number. So now the index will include order date, ship date, and sales order ID, because that's my clustered index key, and it will also include purchase order number. Now, if I run this query again, I can see that I am doing only 5 reads and 1 operation, an index seek. And if I look over at my properties, I can see that it is an ordered scan and it's a forward scan. Those are good things. So that is how we can query for our select statements, or index for our select statements. But there's more. There's always more. What about a query that has an order by statement in it? Now, I know you're thinking, Jess, I always sort in my application. We don't always sort in our application. We may not always want to. We may not always be able to. Sometimes, if you do have to do an order by for sorting, a non-clustered index sorted in the direction of the order by can help you. Let's take a look at a demo showing just how much. So I'm going to stick to my where clause demo table here. I'm going to rerun the same query I just did, selecting the sales order ID and purchase order number. This time I want to order by my purchase order number. And I apologize, due to the remote connection, my mouse is skipping around quite a bit right now. So we're going to go back to the keyboard. So now, before I run this, we have an index, seek, and a select. So now I execute this query. I have, whoa, look at that, 117 logical reads. Note that I now have 3 operations in my execution plan: index, scan, sort, and select. And out of the cost of these, the sort is the most expensive. It's doing a lot of work. Our query cost right now, 2.29161. Let's create a non-clustered index on the where clause demo, which is 1 key column, purchase order number. Again, I'm doing this because I don't have any other things in my where clause, and the sales order ID is the clustered index, so it will be contained. This is a very contrived demo, clearly. Now when I run this, instead of doing 117 logical reads, I'm only doing 55. That's less than half. I've gone down to 2 operators again, simply the index scan and the select, and my cost has gone down significantly to 0.076412. So if I can decrease this cost on this tiny little query, on this tiny little table significantly by indexing for what's in my where clause, indexing for what's in my select clause, and even indexing for my order by clause, I can make my indexes help me rather than hurting me. So to recap there, if your index doesn't contain all of the fields the query needs, for things like your select statement, your where clause, your order by, it has to get those columns from somewhere. It might do an index seek and key lookup. You might see an index seek and RID lookup. It might do a scan of another index. This hurts because it leads to additional I/O. We've seen that in going from 117 logical reads to 55 by simply being able to eliminate a key lookup. So we want to use our knowledge of non-clustered indexes to make them help us rather than hurt us. Remember I was talking about your transactional workloads earlier, and I mentioned that we don't want our indexes to make our data modification significantly slower. How does having multiple non-clustered indexes affect our inserts, updates, and deletes? See, SQL Server is really tricky, and you might not notice what it's doing. All right, going back to our where clause demo, what happens when I insert into this table? I'm going to do a very contrived insert, and I'm going to look at my execution plan. This seems pretty harmless, right? We've got our scan and compute scalar because it obviously has to come up with some values to insert. I look at my clustered index insert, and it appears that it's doing one right. We're just inserting into the clustered index. Beware. Look at your properties. As a matter of fact, expand this way out. Pay special attention to object. Note how it has a little arrow next to it and can be expanded. Guess what? We're not inserting into just one object. We are doing an insert into our PK where clause, into the IX where clause, and into the IX where clause order ship index. So for each insert into this table, I'm not doing just one right, I'm doing 3. This is why significant numbers of non-clustered indexes can hurt you, especially if you're in a very transactional system where you're doing many inserts, updates, or deletes. Now, that particular statement affected all of our indexes, because I was inserting all of the rows. But what if I just update a very specific column? I say set the purchase order number equal to a specific value for a specific sales order ID. I run that. I look at my execution plan. Okay, it's doing a clustered index seek because it has to find that sales order ID, does its computations, and we look at it, and again, we're just doing a clustered index update. Guess what? If we go over to object again, we're not updating just the clustered index. We have the PK where clause, so our clustered index, but we also have IX where clause order shipped, because the purchase order number field is included in that non-clustered index. So again, it's not just insert statements that are affected, but it's updates as well. So be very cognizant of how many non-clustered indexes you have on your tables, and be tracking them to see how many reads are they being used for versus how many writes, particularly in your transactional systems. Too many non-clustered indexes can slow those down pretty significantly. Continuing on with our mission to have our indexes help us, let's talk about Sargability. This is another one of those things that didn't make sense to me for the longest time, but now that I understand it, I realize it can be pretty impactful. You want to be able to go into your plan cache, or while looking at your code reviews for developers, identify non-sargable queries. So what is Sargability? It's being able to use a search, that's the S, argument, that's the ARG, so search argumentability. That was a mouthful, so they tried to make it a smaller word. I'm going to make you guys do some sargable stuff. I'm going to give you a second here, look over the names on this slide. I want you to find all of the names that contain the string L. E-L-L-E. Do you think that's pretty easy? Well, you might have gone right here and just said, okay, well, there's L. And then you might have looked over and gone, ooh, there's Janelle. You might have looked over and gone, there's Rochelle. But don't forget that here we have Danielle. We have to look through Michelle. All right, we constantly have E-L-L-E. So when I ask you to find a name that contains something, how do you find it? You have to read the entire value. You can't just say, well, L starts with an E, so I'll skip to the E's. No, you have to start with the first name and read through the entire page. Guess what? We do this to SQL Server too. A query will look something like this. Very simplified, but we'll say select some values from a table where, and then we'll pass in a where clause like, using typically like, and then we use this wildcard operator, the text value we're looking for, and generally another wildcard operator. We call this a non-sargable query. It cannot use a search argument or a predicate in our where clause, because instead of being able to seek out values that start with E-L-L-E, we're telling SQL Server, read through every row. I want you to look for everything. A quick look at this. A non-sargable query here against my big product table. I'm going to select product ID and name, where the name is like %mountain%. When I execute that query, I get 4,700 results. I'm doing 193 logical reads. And note, I have an index scan. Note that it is, if I look over at my properties, not an ordered scan. SQL Server is reading through every product name to try to find anything that contains the word mountain, and it's finding it. There's HL Mountain, I believe there are even some results that begin with the word mountain. It has to read through the entire thing. The cost here, 0.170261. Okay, so now let's go back to our query and let's try this again. This time, looking at the same set of numbers, I want you to find names that start with ANN. Not anything that contains ANN, but just anything that starts with it. Easy enough. You go right here and you say ANN, ANN, ANN. Jess, I'm done. I found it. Okay. I'm going to make it a little bit harder. I'd like you to find any name that begins with Jen, Jen. You think to yourself, okay, J's, I can skip over A, B, C, D, E, F, G, H, I, J, okay, J, E, A, J, E, A, J, E, N. There I am. Jen, Jenna, Jenna, Janelle, Jenna, Jenny. Who knew there were so many ways to spell Jenna? But essentially, it's that much simpler. We can just look at the beginning of the text and read right through it. This is how we make Sargability queries in SQL Server. Note the big difference, not really a % leading sign. It means that we are able to use a search argument. So going back to SQL Server Management Studio, I'm going to change my query just slightly, and instead of saying where the name like mountain or % mountain, I'm just going to use no wildcard. This is going to reduce my results, 1900 instead of 4700. However, note for that non-Sargable query, we're doing 193 reads. The Sargable, we're only doing 20. Index scan versus index seek. Cost 0.17, cost 0.015. So it is less expensive. So one thing to note here then, the lesson to be learned about Sargability and Sargable characters. If you have a wildcard contains search, SQL Server is probably not going to be able to use the non-clustered index that you set up in the way you intended it to. So searching character fields and indexing character fields can hurt you if they're not being used properly. Again, in my past summit session, the full version, when I have some more time, I'll be talking about some ways to work around that. But know that those wildcard searches can be particularly harmful to you. So, one more mission here for you. You need to be able to understand statistics on your indexes. So let's say that you, my webinar viewers, are my data. I'm SQL Server, you're my data. I am looking at my list of attendees and I see your names. I can tell how many people's first name starts with A, how many starts with C, how many start with E, how many start with S or T. I write all this down because what I'm going to do is ask that everyone whose name starts with a T has to move to a specific table. I know that I'm going to need a table for 20 people. So now let's say the data changes. Some of you have left the webinar because, let's face it, you're up even later than I am and you decide to go to bed. Or maybe it's early morning and the coffee just finished brewing. If you have a fresh cup of coffee, please don't let me hold you back. So now new people are going to come in and fill the spots that were left. This means that the data has changed. The names that were in the room changed. How big of a table do I now need for everyone whose name starts with a T? Do I still need 20? Or should I reserve a table for 5? Or has it changed and do I now need a table for 150? I need to update my records. Data in SQL Server is just like this. Tables and indexes have statistics. The statistics tell SQL Server, okay, I have a range of values from 1,000 to 1 million. I have X amount of values between 1,000 and 5,000. I have X number of values between 5,001 and 10,000, and so on and so forth. So when SQL Server runs a query, it can say, okay, you're going to be returning approximately 10,000 results from this particular query. When I need to join you with this other query, I should do a merge join or a hash join. It uses those statistics to identify what the most efficient way is to get the results back to you. So we want fresh, updated, good statistics. But much like when people come into the webcast and leave the webcast, or come into the conference room and leave the conference room, I need to keep my statistics updated. So does SQL Server, because the data in our database is constantly changing. We're adding new rows. We're making modifications. We are deleting records. People leave. So understanding when statistics are created and updated and how that affects your indexes can really help you in getting some queries set up correctly. So when the room is empty, or when the table is first created, as soon as the first person enters, or the first row is returned or entered, SQL Server is going to create the statistics. Now, if your room or table has fewer than 500 people, statistics will be updated when there are more than 500 changes. So we could have Bob leave and Ted could come in, and then Susan could leave and Aaron could come in, and then Jess could leave and Jen could come in. As long as there's 500 people worth of turnover or 500 changes, SQL Server will update statistics. And it can even be just that a value is updated 500 times. So 2 people could leave. Bob could leave and Ted could come in. And then Ted could say, well, Bob's not here, so I'm going to leave. And Bob comes in looking for Ted. As long as that happens over and over and over again, that will make statistics update. Now our table or our room gets a little bit larger. Once we're over 500 rows, we have to have 500 changes plus 20% of the number of rows. So in this case, if we have a 4,000 row table, we would have to have 800 rows change plus 500, so we'd have to have 1,300 changes. Moving up in the world, let's say we've gotten to a stadium now and it has 40,000 people. We'd need 8,500 changes to occur for statistics about them to be updated. What if we're in a larger city now? Okay, so when the city has 4 million people, we need to have 8,500,000 changes. I have an extra 0. There are 800,500 changes to occur. So what's the lesson that we learn here? Statistics are necessary for SQL Server to return accurate row count estimates to you and get the right joins for your execution plans. The larger the table, the more changes that need to happen. So statistics can get out of date and they might need manual intervention. So you probably have auto update statistics turned on in your database, which is good. That means SQL Server is following those thresholds. For larger tables, you might need to set up a job that runs like SP update stats more frequently. What is more frequently? It might be daily, it might be weekly. It's going to depend on the size of your table and how many changes are needed. You also have one other potential option. If you're on SQL Server 2008 R2 Service Pack 1 or greater, you could potentially enable Trace Flag 2371. Larger tables will then need fewer updates to trigger the auto statistics updates. You can read more by following up this Microsoft KB article. So in short, if your statistics are out of date, SQL Server might make bad choices. You can check if your statistics are out of date by, when you look at an actual execution plan, check your estimated number of rows returned with your actual number of rows. If there's a huge discrepancy, that's probably where it's coming from. You can also run the dbcc show statistics command against a specific index. Or you can run the stats date function using something like sys.stats. Running a little short on time for me to include those in my demos. So again, if statistics are terribly out of date, SQL Server might choose a bad or more expensive operation. So check to make sure that your statistics are fresh, to make sure that you're getting the best use of your indexes possible. And your last mission, after you have identified your workload, after you have identified what indexes already exist, after you looked at your queries to see what kind of indexes could I create to support my top queries, looking at your select statements, looking at your order by, after you've looked for non-sargable queries, after you have made sure your statistics are up to date, you want to make sure the indexes that you have are still being used. And this is going to be an ongoing process, because as our code changes, our index usage is going to change. But understand that as our data changes, so will our index usage. More rows in a table, SQL Server could choose to use a different index. Fewer rows in a table, SQL Server might choose to use a different index. New columns added to a table, data modification to the database might require that you have to change the indexes. So constantly keep an eye on SQL Server to see if you're using your indexes. I primarily rely on the sys.dm/db index usage stats DMV, again built into our XP Blitz index tool. But understand that it's not perfect. When you restart SQL Server, your statistics are restarted. If the database gets shut down, the statistics get reset. In SQL Server 2012 or greater, if the index gets rebuilt, the index statistics get reset. So it might be something that you capture and monitor over time. All right, so to recap, indexes will help you when you have an appropriate clustered index on your data, and it's sorting and storing the data in the way you need it. Your non-clustered indexes help you when they're narrow and help you satisfy the where clauses of your queries. You want your included columns to help support your select clauses and your order by, and you want statistics to be up to date. Indexes, however, can hurt you when you have too many non-clustered indexes on tables that frequently have inserts, updates, or deletes. We saw that it looks very easy in SQL Server, just doing a clustered index update, but chances are we're not. It can help when you don't have enough key columns to support all of the predicates in your where clause, or they're not in the correct order. It can hurt when you don't have any included columns, or you don't have the right ones. An index can hurt you if the index exists, but the query is non-sargable, or if your index statistics are out of date. So to answer the question, are your indexes helping you or hurting you? Chances are, in any database system that you run, it's a little bit of both. You just simply need to know how to mitigate it. And you do this by knowing your workload, understanding what indexes you have, understanding query patterns like Sargability that may not use indexes optimally, and know which are being used and which aren't. So with that, squeaking in just enough to have some questions. Daniel, do you have any questions for me?
Hi, Jess. Yes, I've got a few questions here. Now, first one from Jason Davis. When identifying unused index, how do you determine when to drop the index?
How to determine when to drop an unused index. Typically, I will look at the read to write ratio. I want my index to be used for more reads than it's being written to. And if it's not, I would drop it. However, there are cases where we might have an index that supports a report that's run once a month, where the IT director or the finance director might come barging into our office if it's not done fast enough. So those kinds of cases need to be well documented about why you're keeping them.
Now that leads to the next one. Is there a magic ratio between index scans to index updates?
I'm not sure I understand the question. I will try to get back to that one later. Can we move on to another one, Daniel?
Sure. We've got one from Marcia Wilson. Does a truncate followed by a bulk insert of a table cause an update to statistics?
Can you say that again?
Does a truncate followed by a bulk insert of a table cause an update to statistics?
Okay. Gosh, off the top of my head, I'd have to think about what the truncate will do. I know that a bulk insert is still an insert. Depending on how many rows are added, that should update the statistics. That's a good question. I may add that as a demo for Past Summit.
That's great. Now I've got one from Eric Freeman. As a consultant, when evaluating a database for performance, what would you first look for in general? And he also asks, is SP Blitz Index a free tool?
Okay. So when I look at any given database system to see, is it performing well, there's a lot of questions I would ask. That's probably an entire 24 hours of Past Summit on its own. In terms of indexes, I'll look at things like, do we have any duplicate indexes? I didn't even touch that in this session. Do we have unused indexes? Again, those that have 0 reads but have been written to. Because those are the things that are probably hurting us more than they're helping us. They're making SQL Server make additional, SQL Server has to try to make additional choices when it's picking an execution plan. It has to do more inserts, updates, and deletes when you do any sort of data modification. Yes, the SP Blitz Index is a free tool.
Great. Now, just the last one. Chris Hinson wants to know if you'll be talking about filter index in your Past Summit presentation.
I will not be, but last year at Past Summit 2013, I did an entire session on filtered indexes, indexed views, and compressed indexes. So you could go out to the Past Summit 2013 site and look for that session to learn more about it.
I think that answers.
Okay.
We're getting tight on time. So
I think I've gone back to your moderator slides there correctly, Daniel.
Yeah.
Okay.
So Jes will be presenting at the Past Summit 2014, speaking a bit more about if your index are hurting you or helping you. And you can use the discount code 24HOP14 to get $200 savings. You can follow Jes on Twitter @GirlGeek.
Yes.
Now, coming up next, Kevin Klein will be presenting about techniques to fireproof your IT career, how you can be irreplaceable. That sounds great.
Yes.
Thank you everyone for attending, and hope to see you all. Yes, hope to see you all at the summit.
Have a great day, everyone.
Have a good one.